So if you have an edge on your study area, it might be worth checking out. So I'm standing along a power line corridor through the woods here. You can see how it's brighter there. So obviously a lot more light where they've cleared for that power line corridor. I'll actually jump over there in a few minutes. Here I'm in the forested area to my right. And so then we have a boundary or an edge. We might even call that an ecotone because we have different vegetation on either side of that. And so it's a big difference in light. Right? So in the woods, you can see it's dark. Right? There's not a whole lot of light getting through there, so we're not seeing a whole lot of vegetation on the forest floor. Very different in the corridor. Right? Lots of light hitting the forest floor. And here's kind of a in-between. Right? So look how jungle-like it is along the edge. These trees here are almost creating kind of like an armoring, right? They're kind of sealing the edge. They're loving it, right? So they're kind of getting a whole bunch of light here. They're capturing that. They have no trees on the other side, right? Because that's the mode area. So no competitors on that side. They're just capturing all the light. Take a look at these larger trees behind me that have been here a little bit longer, and notice all their branches are sticking out on this side, right? So there's light over here. They're reaching out for it, so to speak. They're able to do that because it pays off. They're able to get light. No branches sticking this way because that's the forest, right? So there's not light getting down there, so there's no reason to have branches there. So later we'll see a tree in the woods and it's surrounded by forest that has these low branches, right? And that's kind of an indication that it was growing along an edge at some point in time in its past. So we have really pronounced differences in light. We're also going to have differences in, therefore, temperature and humidity as well. So I have a sling psychrometer. I'll show you these in the lecture video, but it's made up of two thermometers, one just a regular old thermometer, right, and a duplicate thermometer that has a wick on, a little cotton gauze wick that I wet. So as I sling it, I'll demonstrate it in a moment here, water evaporates, right? So as I'm spinning it in the air, when I do this, right, water is evaporating off of that one wet bulb thermometer, and that cools it, right? Just like when you sweat, as the water evaporates from your skin, it cools it down. So the thermometer that doesn't have a gauze, the dry bulb thermometer, is just reading air temperature. But the wet bulb is going to be cooler as the water evaporates. And that difference can tell us what the humidity is. All right, so let's see. So I have an air temperature of 72, nice day today. And the wet bulb is reading 62. So it cooled a lot. I also have a little chart that tells me, therefore, that the humidity here is 57%. So we'll compare that out to the corridor, power line corridor, a lot more sun, less vegetation, transpiring water into the air. So if we'll see if we have a difference there. See you then. Here I am in the power line corridor. So let's see what the temperature and humidity are here. So obviously this is a really high light environment, and we're seeing different plants here, right? Obviously they're mowing it here, so that's or treating it with herbicides, whatever they do to keep the trees out periodically. But we're seeing different types of plants growing here than over there. All right, so I have an air temperature of 76 and a wet bulb temperature of 63, right? So a bit different. So that means my relative humidity is 51%. So it's warmer here than we measured in the shade of the forest, and it's less humid here, right? And it's still relatively early in the day, so if I came back and did this late in the afternoon, I think I'd see an even bigger difference. So different light, different temperature, different humidities, the plants respond differently. So later on in a later video, we'll talk about the idea of shade tolerance. So for plants that grow in the forest, they need to be tolerant of shade, right? They're growing in the canopy of the adult or mature trees. These are shade intolerant, right? They need light. And unfortunately, a lot of the weed species, like this barberry here, these invasive species that we'll talk about in a later video, kind of love this environment that we've created for them. Okay, so again, if you have an edge on your study area, take a look at it, right? See how vegetation differs. And you don't have to identify all the plants. If you can, great. But just visually noticing those differences is kind of neat. Okay, one more example tying in that notion of shade tolerance. Where I am now formerly was pasture, and sometime in the past they decided to plant some pines here that you'll see off to my left. They planted pines because they grow fast, right? But they need a lot of light, right? So they thrive there, but they're young pines, you won't see any in the understory. It's too shady for them, so they can't establish under their own canopy. Instead, what we see is deciduous trees have established under the pines that are slower growing, but they're eventually overtaking those pines. And so what you're seeing is mostly mature pines with deciduous trees popping up. And unfortunately, a lot of those deciduous trees were ashes, which have since died because of the emerald ash borer.